Okay, hello everyone. Today we are going to learn about the Demux. Okay, the experimental circuit of Demux is made by this way. As I have already told that for 3 input NAND gate, okay, we need a IC 7410, and for this 2 input NAND gate, okay, we need the IC 7400. Okay, and this is simply the experimental figure of a NOT gate. Okay, it is a NOT gate. We use different type of resistor and all for making NOT gate, but it is a simple method of making. If we give here 1, then 1 comes here, okay, high comes here, then the 0 goes on other side, okay, then 0 goes on other side because there is a bubble, okay, there is a NOT gate. So why do we need this demux? If a data is given from the same connection to different type of NAND gate, so then the control, okay, it depends upon the control A and B, through which terminal the data should be out. Okay, the data cannot be out from all the terminal at once, but at once it can be out from one terminal, at another time it can be out from another terminal. So it depends upon this control. Okay, it is the main experimental diagram of a demux. So this demux is very much important for the term of electronics. So for this we need a 2 IC 7410, 7400. 7400 is a 2 input NAND gate IC. 7410 is a 3 input NAND gate IC. So here is the diagram for 7410 and 7400. Okay, as we have already seen, I have already made a video on this. Okay, 7400, 7410. Okay, I have already told about how to check this IC. So we need only 2 terminals, so we need only one piece of 7400, because there is only 2 compartment needed of this IC. So either we can take this 2 or that up one or whatever you like. Here the numbering is given in such a way that we are going to take this 2, but don't forget to give the plus VCC and here ground. Okay, otherwise the IC do not operate. And here we need a 4 compartment of 7410, that is 3 input NAND gate. But here in 7410 IC we have only 3 compartment, so we need another one more IC. Okay, 7410 2 piece. Okay, and here we need only 1 piece of this IC. So from data we'll give the stable output, which is given by a multi vibrator. Okay, stable output, as I have already made a video. Okay, stable output will be given as a data. It will be input for this term. Okay, that means the data will be up down up down up down. Okay, okay, later on it will be down. So it depends upon this control. So let us see here, okay, how this operates. So if a data is given from here, okay, then if the control is 0 0, if the control is 0 0, then it will be 1, it will be 1. See, this IC is connected to 1 1, so it do not predict the output. Okay, because if this is 0, it will be 1, if it is 1, it will be 0. So this IC is going to work. Okay, this compartment is going to work, sorry, in IC this compartment is going to work. And if the control is 0 0, we are going to get a inverted result in Y naught, because high will be low, low will be high, high will be low, low will be high, because there is a bubble. This high low high low high low, okay, which we'll get from our stable output, we are going to get low high low high low high, okay, in a reverse order. So similarly, if the control is 0 1, then Y1 will be triggered. Okay, this IC will be triggered. If it is made suppose if it is made 0 and 1, then 1 coming from here, 0 coming from here, but from where the 1 is coming? 1 is coming from here. See, in this IC both 1 is connected, but it depends upon this one data. So whatever the data, it will be inverted, and Y1 will give a true result as output. Okay, here the word complement is used, because whatever the input is here, the output will be in a reverse order. So that's why the term complement is used. Okay, so another similarly, if you give 1 0, this IC will operate. Okay, this NAND gate will operate, and if you give both 1 1, this will operate and you are going to get a result. So don't be confused. In this Demux, we are going to get whatever the data is there. Okay, you will see this data in oscilloscope upper side. Okay, and the output will just be opposite. Suppose here high low high low high low, so low high low high low high. Okay, it will be in this term. I hope you are clear on this, why this channel works and how this Demux operates. Okay, here we have seen the working mechanism of Demux. Okay, here the question may be in someone's mind, if the control is 0 0 from here, then from this two terminal, okay, there is a NOT gate, so we are getting 1 1 for this IC, for this NAND gate. Okay, if this 1 and 2 terminal of NAND gate is getting 1, then its output depends upon 13. Okay, so if the control is 0 0, whatever the data is here, if the data is given high for a small interval, then we are going to get a low. If low for certain interval, we are going to get a high. It in my word, I want to say that this data is inverted, because we are going to get a complement for this term. Okay, okay, if in the case of 0 0, what about the other terminal? They are also getting data. There may be a question. Okay, if there is 0 0, then let us see this. This IC is getting this NAND gate is getting 1 from here. If in case of 0 0 1, okay, and here it is getting 1. Suppose here 1 and here 0. Sorry, if it is 0 0, then here 1 and here 0, because this is a 0 line. Then what even? It do not depends upon this data. If any one terminal is 0, it gives a high output. And if there is a high output in DC, we are going to get a straight line. Okay, there will not be this type of terminal, because this predicts the output, because it is 0, because we are supplying from here 0 0, so here 1 1, so the output depends upon this D. And same thing here, because in this 3 NAND gate, okay, in case of this supply of A and B 0 0, okay, these 3 NAND gate are getting at least 1 0, so that all output are high. Okay, do not say that the output is same like this. Okay, because if any 0, then output is already predictable, it is high whatever be the data. Okay, if you do not give data also, it is high. If you give data high low also, this do not matter, because we are getting low, this NAND gate is getting low. Okay, so be sure about this thing. And it is the circuit diagram of Demux. I have given here numbering also of IC. Okay, I have uploaded the video of IC before. Okay, so you can see this thing. And one thing is that we can design this Demux circuit to a MUX one. Okay, I want to show this MUX one circuit. You can see here all the data are combined before. Okay, here all the data were combined and a single data was given. Here all the signal was combined, and but here all the signal has been breaked into a different input, D2, D0, D1, D2 and D3. And what even here we are giving one IC 7420 IC. This working mechanism of this IC is already explained. 1 2 4 and 5 here is mentioned with the double dash, here is mentioned with single dash. Okay, 1 2 3 dash 12 dash, 1 2 13 dash and 12 dash. Sorry, okay, this is 13 dash and 12 dash. Before here also here is 13 dash. Okay, because 1 to 13 and 12 is connected, so 1 to and 13 dash and 12 dash will be here as output. So here in this case of Demux, we are going to get an inverted output, but here in the case of MUX, we are going to give a same type of input from the astable multivibrator. Okay, high low. So what even? Let us see if the control is both control is 0 0. Okay, over here, then what even this will be activated. This will depend upon the data. Okay, if data is high, it will give low. If data is low, it will give high. Then what even here we are going to get a inverted of this. Suppose for here we are giving D0, then from here we are going to get D0 complement. Okay, That means high will be low, low will be high. Okay, and what even this denote complement is coming from here, and it do not predict the output because it is high for a limited time, low for a limited time. Then what about the other? Okay, let us see. We know at the case of 0 0, okay, at the time of 0 0, this um, NAND gate is getting at least 1 0. See here, this is getting 0 from B, this is getting 0 from A, and this is getting 0 from A and both B. Okay, see here, it is, so the output of these all will be 1 1 1. So if all 1 1 1 comes from other 3 NAND gate, then what even this will be activated, and it will depend upon this one, because if it is low it will give high, if it is high it will give low. So here what even we are going to get a, if d naught is given from here, it is not a complement. Okay, if d naught is given from here, or stable d naught, then we are going to get a d naught complement, because there is a bubbled. Okay, and when this d naught complement is given giving signal to this NAND gate, then we are going to get a d naught as output. But where this complement goes, because of this bubbled, it is again being complement and it is d naught. Okay, so whatever the data is given here, same type of data is output. So suppose you can see here d naught is high low high low, here is also high low high and low. And similarly, if you give the signal 0 1 to this A and B, okay, same thing we can predict for this also. Okay, same type of diagram. A and B, if you give 0 and 1, then this will be activated. See here, if it is 0, it is not connected with 0. If it is 0, then this will be 1, this line will be 1. So this IC is connected with 1, and this is already connected with 1. If you give 0 and 1, then this will get 1 1. So it depends upon this d1. If signal is given to d1, then we are going to get d1 complement, and from here we are going to get d1 as an output. So this is a simple diagram of MUX. And similarly, if you give 1 0 and 1 1, this and this IC will be operated, because this arrangement is done in such a way that we are going to get a same type of output. Okay, thank you very much till here for watching this video. Okay, please don't forget to leave a comment. Okay, thank you very much.